Division of a line segment in a given ratio. The coordinates of the point or x, y, which divides the line segment P, x1, y1, and Q, x2, y2, internally in the ratio a to b is given by or x, y is equal to b multiplied by x1 plus a multiplied by x2 all divided by b plus a, comma, b multiplied by y1 plus a multiplied by y2 all divided by b plus a. So if this is the line P, Q, this is the point or xy, so this is the point we end up getting when we use this formula. So this is the point P, which gets labelled x1, y1, and this is the point Q, which gets labelled x2, y2. So that's where the x1, the x2, the y1, the y2 come from. And from P to or, we have our a value. So that a there, this a, that a, and that a there, we all get from this value here. And the b we get from here. So that b, that b, that b, and that b. So for example, if this was the ratio of 3 to 2, if this was 3 parts to 2 parts, then the a would be the a would be 3 and the b would be 2, and so on. So when we sub all these values into our formula, what we're left with is the point or. So the coordinates of the point or x, y, which divides the line segment P, x1, y1, and Q, x2, y2, internally in the ratio of a to b is given by this formula. So we use this formula to find this point in this ratio. Note, you can avoid using the formula by using similar triangles or translations. Note, the syllabus states the internal case only. However, the unknown point could also be at the extreme, i.e. the unknown point could be P or Q above. So we're always going to be given P and Q, which are the two external points, and we're going to be asked to find the internal point that's in a certain ratio. So again, the ratio could be 3 parts to 2 parts, 3 to 2. So we're always going to be asked to find the internal point. And to do that, we use this formula. A minus 4, 3, and B, 6 minus 12, are 2 points. C is a point on AB, so on the line AB, such that AC to CB is equal to 3 to 2. So the ratio is 3 to 2, 3 parts to 2 parts. Find the coordinates of C. So method 1 is to use the formula, and what we're going to do is draw out the line so we can see what we're talking about. So this is the point A, this is the line, this is the point B. So A is the point minus 4, 3, which we label as x1, y1. B is the point 6 minus 12, which we label x2, y2. We know that it's in the ratio of 3 to 2, so 3 is the A, 2 is the B. So it's in the ratio of 3 parts to 2 parts. So we're trying to find this point C, this unknown point. So we use the formula that we saw on the last slide. We swap the B for 2, the x1 for minus 4, the A for 3, the x2 for 6, the B for 2, and the A for 3. Then we have a comma. We swap the B for 2, the y1 for 3, the A for 3, the y2 for minus 12, the B for 2, the A for 3. And you can put it straight into the calculator if you want, and you'll end up with 2. And again, straight into the calculator, you'll get minus 6. So the coordinates of that point C are 2 minus 6. So now we're going to have a look at using a translation. So under the translation a minus 4, 3 to b 6 minus 12, we consider the translation of the x and y coordinates separately. So to get from minus 4 to 6, the x coordinate increases by 10. So minus 4 plus 10 is 6. And 3 plus 2 is 5 parts. That's the ratio that was given. So 5 parts is equal to 10. So dividing by 5, we say 1 part is equal to 2. So 3 parts must be equal to 3 multiplied by 2, which is 6. So we start at minus 4, and then we add on 6 to the minus 4, and we get to 2. So our x value is 2. Now we focus on our y coordinates. So our y coordinate is 3, and to get from 3 to minus 12, we decrease by 15. 3 take away 15 is minus 12. Again, we have 3 plus 2, which is 5 parts. We got that from the ratio. So 5 parts is equal to minus 15, so dividing by 5, 1 part is equal to minus 3. So 3 parts is equal to 3 multiplied by minus 3, which is minus 9. So 3 minus 9 is minus 6. So our y value is minus 6. So same answer as before.